I hope you're all enjoying your vacation. And myself, Ashrita, and the other person is Akshaya, who is going to join with us. And we are from the Mars Club. So today we are going to give the basics and fundamentals of what actually OpenCV is and the implementation of some code part of the OpenCV. So let's start. Like I guess all of you have used or experienced your Snapchat filters or Instagram filters that you get your on your phone, right? So have you ever wondered that like how does that work, or like have you get any idea? So that actually is done by the computer vision that comes into the action here. So today we are going to explain that magic behind these all the technologies and like give you and basic idea of image processing world. So yeah, and let's go. Akshaya will be explaining you basic first implementation of what OpenCV does. So let her continue that.
I hope it was. So let me show you guys. Okay. So you guys can see this detection, right? So by the end of the session, you will know what exactly is this, how to write the code of this, and why is there so much noise? Why am I also red? So we'll continue with the session.
So yeah, um, what Akshaya has shown you that is what actually computer vision OpenCV is. So what exactly is computer vision or CV? Computer vision is something similar to a human vision. What like how a human eyes sees, interprets, and understand the images and as well as the videos. Similarly, a computer vision also does the same thing. Like CV is basically an amazing and interesting field at the like intersection of machine learning, neural networks, and as well as image processing. So to have a basic idea of all these three, let me give a one-line definition of all those. So what actually machine learning is? Uh, like it's basically teaching the computers to recognize the patterns in the data or the image that it collected. And coming to the neural networks, it always like mimics the human brain to process the complex visual information or the data that it collected from the machine learning. And coming to the image processing, this manipulates the images to extract the meaningful information. I hope you all get what actually the computer vision does. So let's go like how does this computer vision work? So what if the computer sees like how what if our human eye sees? It first sees the input and then understands it through our brain, through our neurons present in our brain, and then process it and then gives an output, right? So that we understand that that particular image is a cat or a dog as we see in that image. So similarly is the computer vision. It takes an input, and that input can be either image or a video, and then processing is nothing but analyzing the visual data, breaking that into pixels and features, which will be explained later by Akshaya. And then coming to the interpretation, the data or the analysis, what it does in the previous step, it based on that it identifies some objects or patterns or even some emotions also. And finally, based on this identification of the objects or patterns, it finally makes decisions like adding filters to your face or unlocking your phone or something like that, and finally gives an output. So yeah, Akshay will continue from.
So I would like to give you an overview and then jump deep into it. So as you can see, an input image can be of two types, either grayscale, which is basically black and white image, and another one is colored, that is RGB. So as you can see, this black circle, generally in OpenCV, when there's a black color, it is considered as zero. The range, pixel range, which I'll tell you what it is zero. And a white shade is generally considered as 255. And anything in between, like gray color, will have ranges between 0 to 255. Now, if suppose I want to see like 20th row and 20th column, that is black here. So it is 0. And in the same way, if 20th column, 40th row, it will be 255. That is white. So that's how you see an image in OpenCV. In the same way, you can define a colored object, colored image as RGB values. All these values, these 0 to 255 or RGB values, are intensities of an area. So, how much of an intensity is red or green or blue? So, that decides the color of the image. The same way, you can define like 20th row, 20th column, what is the color? So as you can see a blurred image in the start, and when you closely look into it, you can see many numbers. These numbers are what? Intensities. So it's saying how black or how white the image is, that pixel is. So basically an image is a collection of pixels. It is a in black and white, that is grayscale, it is a 2D matrix because we have only two colors, black and white. Whereas when it comes to colored images, you have three tuples. Tuples is a Python function where it stores data in order. So it is a 3D matrix where you can store values of R, G, and B. And these RGB and B values show how much intensity, as I told, how much is red, green, and blue's intensity. And also, these values are 8 bits. If you know a little bit about bits, you'll know that this can store 8 bits, which is if you want to store RGB's value, it should be 8 into 3, that is 24 bits. Now, Ashrita, you can continue.
Yeah. So, like what we have seen, the how the image is converted into pixels and features, right? So now we'll like look into the implementation, like how actually OpenCV reads an image. So let me screen share. So yeah. So here is the import CV2 and then import NumPy as NP. These are like two libraries. The first one is CV2 module, which is a OpenCV's Python library that we'll explore in the coming part. And NumPy, I hope all of you are aware of it. Like it mainly handles the arrays in the Python. Like we have seen that image is in the form of pixels, which is in the form of basically 2D array or a 3D array based on the image color space. So for that we have to convert that image into pixels and then arrays, right? So for using arrays, we are using here NumPy. Here cv2.imread. Imread is a function of the cv2 library where it takes input of image file name or image path from your computers or files, and then it will store that image in this img variable. This is basically an image. Now imshow is another function which like it gives an external pop-up window that displays the image so that we can see it. It's especially useful like when you are working step by step and want to check how each operation is affecting that particular image. And coming to the image color space, that what actually OpenCV takes by default is OpenCV loads the image in a BGR color format. Like BGR means blue, green, red. Like which means that each pixel in the image is described using 3 colors values like blue, green, and red. This is actually completely different from the usual RGB format, which is red, green, and blue, and the most people expect that. But the OpenCV defaults color space is BGR. Each pixel is just a tiny dot with color, and thousands of these makes up the whole image. And as Akshay has explained you that. So Now let me, and this is a wait key, because if I don't write this a particular line of code, the pop-up window which we get from the IMShow function will be just only for fraction of second, and then it will go off. If we give the wait key function and use that, it will wait for this particular number of seconds as we give the argument. Here 0 means like indefinite time until the user presses any stop from the keyboard or control C like that, or else if we type any like 1 or 2 like that means it basically stops for that number of seconds. So let me run this code and show you the output. So yeah, this is like, yeah, I have given the check1.png is the image file name. This is what check1 image is actually. Here I have stored in my folder. That is what I have used here, and then from using OpenCV I am getting this image. Yes, this is basically a BGR format. Like suppose if we want to give to check another image, we have another image like marks.png, so we shall see that also. So if I change the file name, based on that it will give the image output. So I hope everyone have understood like how OpenCV reads an image. This is basically a BGR format, not RGB format. Then now let's actually go into the hands-on experience. Like basically we'll be detecting uh, some colors, like we'll be detecting brownish shade colors from from these images, and show you how actually we can detect a particular color. So as you have seen this, these are two Python libraries, and then you have already just now I explained that how to read an image. Now let's find the difference between RGB and BGR images. So CVT color is a function from the CVT library itself. This is nothing but this is a function changes the way the image stores the color information. Like for suppose I have used here color RGB to BGR. It's nothing but it changes the color space of RGB to BGR format. So like RGB is nothing but it stores the image in the format of red, green and blue. After using this function, the image is converted into blue, green and red, which is a different color space. So color spaces are nothing but how colors are represented in the format. So basically, as I have already said, the OpenCV default stores in the BGR image, BGR format color space. So I'm converting that into RGB format. And then RGB format is again converted into BGR format. So let me show you the difference. There is actually one slide that describes about the BGR and RGB in PPT. Akshay, can you once show that? So yeah, this is an original image that is pink color, and then if we use that is RGB image, and then from the OpenCV what we get is BGR image, that is blue color. Now let's
So
convert
basically,
that.
I wanted to add one thing. Am I audible?
Yeah, yeah, you're.
Uh, so in general, the like JPG format or PNG format, these images are stored as RGB, but OpenCV takes it or processes it as BGR. So when you read the IMRead function, it automatically converts this RGB to BGR format. Ashita, you can continue.
Hello, am I audible?
Now you're audible.
Acha, okay. I was not aware. Yeah. Let me show that. So as I explained you already. So yes, this is the RGB image actually, and this is original image. I hope you're all able to see the difference. This is the original image, that is BGF format.
I think your screen is not visible. Screen share it
Sorry,
once
I was,
again.
yeah. Is it visible now? Hello.
Yeah, it is. It is.
Yeah. So this is actually original BGF format, and then this is RGB. As I have converted from BGR to RGB, so what we get the image is this. And basically this while true statement is nothing but if we press any Q, as I have already said, that we can write either 1 or 0 like number of seconds, or we can give any keyboard input that can be Q. Based on that, if we press that key Q, it will destroy all the windows, and then it stops the running of the code. Now actually, this RGB and BGR images, they have a small limitation actually. Uh, the, very small, like under lighting conditions, they actually changes the pixel values, but HSV is something another color space which separates the color from lighting effects, which makes it more better and easier for the task like object detection based on the color, what we are actually doing now. So let me explain what actually HSV is. H stands for hue, S stands for saturation, and V stands for value. Actually, hue represents nothing but the type of the color, and saturation is nothing but the pure or intensity, or you can say the vibrance of the color, whereas the value indicates the brightness of the color. So this is really helpful in under different light conditions. Now let me convert that image into HSV format. So yes, here you got this HSV image. This is what we get from while we convert that BGR to HSV. Now, uh, like all of you know the color palette, right? Here is the color palette. So if we want a particular color, suppose we say that red color. If we want the red color, this red color will be having like not one intensity value. It will be having many number of intensities that can range from this side to the center. So we can't say that this particular intensity can be red color. uh, so it will be having some range of colors, which will be using that, taking that as a lower bound and upper bound, and using that range of intensities, values and pixels, will be detecting that color using OpenCV. So here is the code. These lower bound and upper bound values are nothing but, as I have said, these are not single values but a range of values. In this color brown in HSV might have the hue values like from 10 to 25 and then varying saturation and hue values. Here 10 stands for the lower hue value, 50 stands for the lower saturation value, and then this 50 stands for the lower value. HSV similarly for upper brown. Basically this hue, lower hue, what is that, from 10 to 25, this ranges from orange to light brown shades, and then from 50 it includes like pale or grayish tones, and then the other value, that is last V, this indicates all brighter shades of or dark pixels. So we use that to detect the brown shades, brown color of the terrain, what I have shown you in the image. We are taking those two as upper bound and lower bounds, and then using them. Now coming to the masking of the image, I'll explain you what actually is masking. So yeah, a mask is like a filter that tells you which parts of the image match your color range, that is lower bound and upper bound. So that are the arguments what I gave, like HSV is the image and the lower bound is the values that starts the brown shades, and upper bound is the values, that the range of values that ends the brown shades. So this cv2.inRange function checks every pixel in this HSV image, what we gave as an argument, and returns a new image, that is brown mask, where pixels that fall within this range are turned into white. So masking is nothing but the color range what we'll give as an argument, that will be shaded and will be given as white color, and the other which are not in that range color will be as marked as black color. So that is 255 as white and everything else is black, 0. So the mask becomes a black and white image that highlights only the areas that with a desired color what we give the ranges as lower bound and upper bound. Here the desired color is brown. So this is really helpful for isolating the objects based on the color and is often the first step for the object detection. Let me run and explain you. Let's save this. Yes, here is the brown mask. Here you are able to see brown shades, right? The objects detected, and then here is the white shade. From the image, you are able to see that these all is brown. These all is considered as a terrain or brown color, brownish shade, and the other, which are the different colors like brown, yellow, black, yellow, green. Those are marked as black shades. Black. See, you are able to see here, right? These are considered as black because we are not considering that range of pixels, that range of intensities. So this is what actually brown masking is. Now coming, like we have explored how to convert from one color space to other color space, and conversion of BGR and then to RGB and then HSV, and then we explored like why HSV is important, and then we detected something based on one color, and we saw that how this color can be detected, but we are not aware that exactly how can we extract that information from this particular image, right? So for that we use something like counters. Counters is nothing but the outliers, the borders of the objects in an image. So for like in basic simple terms, it's like drawing the outline around a shape or an object in an image. Like a rectangle or a square or a circle. If we see the object, then if we draw any outline for that, then it is called as a counter. Why are we using counters here? Because so to get the to extract the information from that image, from the HSV or brown mask image, what we have done till now. So from here, Akshay will be explaining you the implementation of the counters, and then there is another code that she'll explain you where you can detect more than one color. This is basically till one color you have detected right till now. Now she'll explain like how to detect two colors at the same time. Yes, Akshay, you can continue.
Yeah, okay. Okay. So I saw how to read an image. So I'll show you.
I'm just look out through images.
Second. So this is what Ashita told, right? How to read an image. Over here, I'm my passing the image to be read. What if I change this and tell to read my webcam? If I want to do that, I'll just give 0 here. So hi, I'm visible. So this is how you can access your webcam. Let's get into it. Okay. So now if I want more than two colors, for first starting basis, I'll tell you how to detect one color, that is red. Now this this is what Ashita told. You have to import all the necessary libraries and and the CV2, and then you tell the computer to access your webcam. After that, you create your own dictionary. This is my dictionary, which has the values of red, green, blue. So because I want to only detect these three colors, so I kept only these three. You can keep n number of colors. So what does this say? np.array. So Ashita explained you hue value, like HSV values, right? Can anyone tell me the full form of HSV? Anyone? No one? Okay, HSV is hue, saturation, and value. So I am defining these values of red here in my color dictionary. And I tell the computer to read the webcam. Read. If there's nothing, it will just tell me that no camera is detected. And if it does, it will continue to change it from BGR to HSV. So, as Ashita already told, why we need to convert from BGR to HSV, we convert this and then keep it in a frame called output. This frame has a converted version of BGR. Now, since I have this version, now I have to just match this image with whatever color I want to detect to. So I run a loop where I'm just checking my dictionary. So this is saying color name ranges in color ranges.item. So color ranges.item is this. So I'm checking what and all is there in my dictionary. Right now it's only red. So it is what exactly it's doing is creating a mask. Mask is where it just opens an empty file with everything zero, and whenever a red color is detected, only that pixel is turned to 255. So we have mask image of red color. So wherever the image has red color, it will turn that part as white color. So now we have black image with white pixels in it. Now since we might have different shades of red, right? So here it is like lower shade and a higher shade, so it can have multiple shades. So if I have like these multiple shades, I have to create a mask for everything. So if I create mask for like lower shades of red, it will only capture lower shades in one mask, and in another mask it will capture only higher shades. So when you have to combine these two, you do an OR operation and show that to pass it to another bitwise operator, where you just combine all the masked images with the real image. I'll show you how that looks. if it is red. So what it's doing, first it was creating a mask. First this was white in color, but I'm passing this to a bitwise operator which is comparing it to my real image, that is the webcam, and seeing the mask image, so it will show me the red image. Okay. uh, then contours, as Ashrita told, what is does, see, what you're doing is seeing which pixel is red. So if you get many pixels red nearby, it will create a kind of boundary there. So it will create bulb blobs of red color everywhere. Then what you do is there's an area function where you check if the area is more than 500 or 1000. If it is more than 1000 pixels or 500 pixels, then it only considers as a red color spot. So you remember I showed you my face was detecting that also as red. So sometimes that's noise, because you're considering even smaller pixels which show red as red color. You can avoid that and only tell ki above 100, above 1000 or 1500 pixels, then only consider it as red. You will have a more clearer detection. So you can play around with this value and then know which is better. This cv2.rectangle, this is a function in OpenCV where you can create a boundary, like counters are already creating a boundary, right? So it will get the x and y values and create a rectangular boundary, like how I showed on the webcam right now. It will just create one boundary showing that this is the detection part. And the dot put text will tell you which color it is. So on top of the rectangle. So this if I want to do it with one more color, let's assume I do it with blue. Yeah. So this is red. I don't have mine blue. So wait, you can see it is detecting both, and see my face is also detected as red sometimes. That you can play around with the pixel area values and figure out which is correct. And okay, also I wanted to explain one more part. Remember, I told you to change few values here. I was changing this to 0 whenever I wanted to see an image. That's because it is waiting indefinite number of time, matlab indefinite number of minutes or seconds, until you read the image. So if you give 1 second, as Ashrita told, it will probably take 1 second to read the image. So if you give 1 second to read the image,
Hello guys. Yeah, I guess she has some internet issue. You guys have any doubts regarding like till what we have explained? Yeah, if anything is fine, whether it's small or big. Yeah, anyone, or you want to share anything? Okay, guys. How many of you got interested in this after listening us? Like, how many of you are aware of this OpenCV before? Oh, that's nice. Okay.
Oh, sorry guys, I got disconnected.
Yeah, yeah. You can continue.
Yeah. 1 minute. Um, so you guys saw the detection part, right? Both red and blue. Or did
Play it
I
again.
not show it?
Yeah, play it again.
Uh, Acha, okay, okay, okay. Um, okay. So this is red, and my mouse is blue. You can see both the color detection, right? And I would also like to show you one more thing. It's for blue. So when you do only color, like when you want to mask it, like this is a bitwise operator, right? And you want to mask it only to a particular color. You can't do it for two colors at the same time. So you have to write two different functions and show it. So I think this is quite accurate, right? And I wanted to tell here. Remember, I was playing around with like 0 and 1 when I was changing from reading an image to showing my webcam. So if I keep 0 here, I can see an image for indefinite amount of time. If I keep 1, it will show for 1 second and then go off. Or if I keep 2, it will go for 2 seconds and then go off. So 0 is just telling you that it will stay for indefinite time. But if I keep this 0 for webcam 2, what it does is, can anyone tell me what a video is? Like, what exactly it is? Have you guys heard of the term like 25 FPS or 30 FPS? What is that? Anyone?
It's like 25 frames per second. So it's like 25 images that are playing throughout the duration of a second. So
Yeah,
that you
exactly.
can perceive it as a video.
Correct, exactly. So when I keep 0 here, it's saying that for every frame, it's waiting indefinite times, and then it's waiting till you press any key. Like here, I've given Q. So for every frame, it's waiting indefinite amount of time. So when I'm running this in a loop, it's just stuck in the first frame. So if I run this, I'm stuck. Oh, I'm not stuck. 1 second. Uh, so see, you can see that I'm stuck in this image. That is because it's waiting in the first frame till I press Q there. So I have to keep here 1 or 2 second 2 millisecond value, so that in every frame it will just wait for 1 milliseconds and then go on to another frame, so that the video keeps on going.
So I hope you all have understood that. So, like we are likely to give one simple project that we want you to detect some other object, some object detection based on the color itself, what Akshay has shown you, and we wanted you to do that and post and tag us so that we can post it in our story. And if you want to still more explore on OpenCV and you are interested very much, then you can try something like what real world based applications like Snapchat filters, QR code scanner, what actually Google Lens does, and barcode scanner similarly. And if suppose someone is playing the football or some any game or something else where there is a motion, you can track even that also using this OpenCV. And using this OCR is nothing but optical character recognition, where you can recognize some characters like alphabets A to Z, whether it can be small or capital, and then numbers from 0 to 9. It can be any character you can detect from using this OpenCV with your camera. So these are like really very interesting and interactive projects. You all can try them. Yes.
So, guys, first go and try the simple code which we taught you
Yeah.
today
First
to
try.
detect a color. Like, yeah, first get started, and then you can take a photo of yourself and screenshot or anything and send it to Mars account. We'll reshare it. And we have added a website link. This is a OpenCV free bootcamp session. Like, you can join it for free. Okay.
Hi D.
Hello.
And actually, I was making one project on gesture recognition. So I had
Okay.
used OpenCV and MediaPipe there. So I just wanted to ask that are there any OpenCV techniques I can use to improve the camera input, because it detects the um, posture of the fingers or whatever, but the accuracy drops when the lightning changes, so that I can make it more reliable in different lightning conditions.
Okay. You mean you want to detect gesture properly
Yeah.
even in bad lighting conditions?
Hi, in bad lighting condition. Yeah, in proper lighting it detects it properly, but in
Okay. Are
different
you
light
like
conditions.
masking it to black first? Black and white fully?
Not black and white, like in dim light, it can just detect the gesture so that it can work properly.
Okay, I'm not so sure, but whenever I tried color detection or something, I convert even alphabet detections. I grayscaled it first fully, and then try to detect through the grayscaled output. So you can try to do that and see how the
You can
accuracy
also
is.
like as I said, you can try converting that into HSV form. Did you do that? Like it's very
Uh,
useful in under lighting conditions.
no, I haven't tried it. I will try once.
Yeah, you can try that converting image into HSV format, and also additional to that, you can use some blurring or smoothing filters, like you can
It
say some.
actually uses live webcam feed. Like when you just run the project, now the webcam will be activated and your gesture will detect whether it's what function it has to do. Like for palm, it will play or pause the video or something using other gestures,
Uh,
something to.
then you can try the HSV, but it works
Yeah,
on
you can
live
al-
detection.
yeah,
Mm,
yeah, it
okay.
works on the live detection. We tried it. You can also use Gaussian blur and bilateral filter. Those both are like smoothening
Yeah.
filters that actually makes
Like
the video frame very smooth.
blur was actually helpful. I tried it for OCR. I'm not sure about live webcam, but yeah, you can give it a try.
For image,
Okay.
actually, it works very well.
Okay, okay, I'll try that. Thanks.
Yeah.
Anyone else has any questions? Okay, guys. Thank you for joining. It was really fun.
Yeah. Thank you.
Bye
Thank
bye.
you, Akash. It was a very nice session.
Oh my god, thank
Thank
you.
you.
Yeah.